Assalamualaikum, hello and welcome to the video. This video is made by the students of University Utara Malaysia, class Mathematics for Information Technology, Group B in A221 session. This video will be talking about quadratic functions from the topic calculus. Before we start, let me introduce our group members. My name is Danish Salikin bin Muhammad with the number matrix 295501. The other group members are Muhammad Alif Ramadan bin Muhammad Rejal with the number matrix 293977, Muhammad Khawarizmi bin Muhammad Suzaimi with the number matrix 294489, and Muhammad Faiz Ikmal bin Azwan with the number matrix 288136. Without further ado, let's jump straight into the topic. First and foremost, what is quadratic functions? A quadratic function can be defined as one of the form f(x) equals to ax power of 2 plus bx plus c, where a, b, and c are numbers with a is not equal to 0. This means that in the equation, the a constant will always have a value, doesn't matter if it is in negative or positive form. But why does this happen? This happens because if a is equal to 0, then the equation will no longer be quadratic. Instead, it will be linear equation, and anything that multiplied by 0 is always equal to 0, because nothing added to nothing is still nothing, and this will make the ax square part disappear, leaving with just bx plus c equals to 0. Since there is no longer an x squared term, it means that it does not have an quadratic equation, which what we are going to learn today. Okay, for example, if we have these functions f(x) equals to x squared minus 3x plus 2 and ft equals to negative 3t squared, are they a quadratic functions? The answer is yes. But why? This is because it is written in the form of f(x) equals to ax squared plus bx plus c. How about the function f(x) equals to 1 per x squared? Nope, it's not a quadratic function. Why? The reason is simple, because it is not written into the form of f(x) equals to ax squared plus bx plus c. Alright, in this subtopic, we are also going to learn about quadratic functions graph. The graph of the quadratic function y equals to f(x) equals to ax squared plus bx plus c is called a parabola and has a shape like the curves in the following figure. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U shape. We call it the smiley and the sad U shape, whereas the smiley U shape is for the upward curves, while the sad U shape is for the downward curves. Next, the quadratic functions graph for f(x) equals to ax squared plus bx plus c. As you can see, if a is more than 0, the graph extends upward indefinitely, and we say the parabola opens upward. This means that the graph would be like a smiley U shape, whereas if a is less than 0, the parabola opens downward, and this means that the graph would be like a sad U shape. Okay, so now we're going on to the vertex. What is actually vertex? Vertex is the lowest point of the parabola and also the highest point. This means that f(x) can have a minimum value and a maximum value of the parabola. What is y-intercept? Y-intercept is the point where the parabola y equals to ax squared plus bx plus c intersects the y-axis. that is the y-intercept occurs when x is equal to 0. The y-coordinate of this point is c, so the y-intercept is 0, c. How about x-intercept? The x-intercept occurs when y is equal to 0. There are three types of x-intercepts: for a more than 0 and also for a when less than 0. There is three solutions, which is one solution for x, two solution for x, and also no solution or no x-intercepts.
Per the chapter, the information before we read question is given the following quadratic function f(x) equal 3 in bracket x minus 7 power of 2 plus 30.
Let's move on to the question. This question want to find the vertex for the function. To answer this question, the early step we need to do is identify the vertex formula. The vertex formula is negative b per 2a for x coordinate, f in bracket negative b per 2a for y coordinate. So from the formula, we identify we must know value for a and value for b. So we change the raw form function to parabola function, that is y equal ax power of 2 plus bx plus c. After you get the value a and b, you just replace it the value and you will get 7 for x coordinate. After getting the x coordinate, we can replace x with 7 in the previous equation and you will get 13 for y coordinate. So for the coordinate, x is 7 and y is 13.
Let's continue our lesson by doing the next questions, which is questions 8b, which are taken from our quiz 2 questions. Okay, let's identify the questions first. 8b, find the y-intercept and x-intercept for the function. Firstly, to avoid common mistake, we should underline the keyword and the requirements of the questions. Students often do forget what they were finding or calculate. They just leave the answer as y coordinate, even though the answer is correct. We have to declare in our calculation that the answer is y-intercept or x-intercept. The examiner will not searching your correct answer. So for these questions, we should highlight the required, which are y-intercept and x-intercept. Okay, so in order to find the y-intercept, let's look at the notes before. Y-intercept is the point where the parabola y equal to ax square plus bx plus c intersects the y-axis, that is the y-intercept, occur when x equal to 0. The y-coordinates of this point is c, so the y-intercept is 0 as x-coordinate and c as y-coordinate. So, to find y-intercept, at first we must change to this form so that it can easier to find the y-intercept. So since the function is fx equal to 3x minus 7 square, is not the form that we needed, so we must change to this form first. So after we change into parabola form, we should get the answer as 3x square minus 42x plus 160. But that's not the final answer yet. After we get the questions in the parabola form, we sub the 0 into x, since to find y-intercept, x must be equal to 0. So after we sub, we should get y-intercept equal to 0 as x coordinate and 160 as y coordinate as our final answer. Okay, let's continue our requirement. to find x-intercept of the function. Since we already obtained the parabola form from the y-intercept, we can just reuse it to find whether there is x-intercept or not. Okay, since to find x-intercept, fx is sub to 0. So in this case, there is no interceptions of x within these quadratic equations. So that's all for this type of questions. Let's move to the next questions. Thank you.
To do this question, first, you need to plot the vertex found in question 8a, which is 7 and 13 into the graph function. Then, after you have plotted the vertex, you need to plot the y-intercept that found in question 8b, which is 0 and 160. For the last step, after you have plotted the vertex and the y-intercept, now you can graph the graph function, but please make sure that the arc passes through the y-intercept and vertex point.